My event has started, which means that it is me, Dan Schiffman, coming to you again for the second time today, for the third time in 2 days. This is probably really not so advisable. There's a lot of reasons why I shouldn't be here, but I am here. And I have about 1 hour, so I'm really going to jump right in. I think I might actually even call this, dare I say, a coding challenge. The thing about this, it's okay. This is not the important thing to talk about. This is the topic for today. Linear regression using TensorFlow.js. Now, before you all start going and running away, which would be completely understandable, I'm really doing this for a couple of reasons. Number one is I have started a series of TensorFlow.js tutorials, just looking at some of the basic features of the API, and I want to at least get into an example or actually using the stuff for some purpose. Now, what kind of, this is really foundational knowledge. It's kind of like a classic example of the beginning stages of machine learning. I have actually made some videos about this already. Notably, this linear regression with gradient descent video that I made just with plain JavaScript. I also made this ill-advised video about the mathematics of, underlying audio is not working. All right, well, hold on, I won't worry about that. Let me just check the chat here. Okay. This video about the sort of mathematics of gradient descent. So these would be two pieces of background. You're watching this live, so you probably don't want to stop and go watch those, but you could, okay. And so I think this is going to be helpful in terms, and so first of all, thank you. I'm going to be saying all this stuff again in a second because I'm going to, but just bear with me, please. Thank you. You're very kind. Thank you to Olpodcar on Twitter, who posted this code for an interactive simulation of linear regression with TensorFlow and P5.js. This gave me the idea. You can read in this thread. Oh, great work. I wonder if a video tutorial redoing my linear regression example in a similar fashion would be useful. And then the reply was, thanks, yes. And some other people replied and thought this would be useful as well. So that's what I'm going to do. This is foundational knowledge. Let me see where does this appear? Where? Under here, this is all my neural networks and machine learning playlists. We're looking for this one, session 6. So this is what I've done so far. And the thing that I really want to get to, which is going to come next week, is the layers API. And this is where I'm going to actually begin building some neural network examples and remaking some previous things I've done on this channel without TensorFlow.js. But I think before we get there, I want to just look at some other features of the TensorFlow.js library in the context of linear regression. So that's the plan for today. Okay. So I think I just want to get going. So I need to reference all these things. I guess I will just tab my way through them. I'm going to move this here. And I haven't implemented this. I scanned over this GitHub user's code. So I do have that a little bit in the back of my head, but I have not tried to implement this myself. I've got the chat going, the Slack channel going here for patrons and YouTube sponsors. Thank you. So I'm gonna, you'll be keeping me in check. And I've got until about 5:30 p.m. I'm just trying to decide, does this sit as 6.5 linear regression with gradient descent, or is this a coding challenge? So I'm seeing in the chat that a chat user says, if you want to do interactive stuff with TF.js, you should check out TF NextFrame. Okay, hold on. I was not aware of this. So let me have a look at NextFrame. Returns a promise that resolves when a request animation frame has completed. Oh, fascinating. Oh, interesting. So that's really interesting. I think I'm going to do, this is, right. So what I'm doing is so incredibly, well, is comparably simple and I can probably do it with pulling the, yeah, let's see how this goes. Let me try to build it, and thank you for this note. I'm going to try to do it probably in a less correct way and just get it kind of working. Let the threads kind of like, and the amount of computation that I'm going to do for linear regression is so simple that even if it locks up for a second, that it's going to be fine to let the animation keep going. But this is absolutely something that I will need to pay attention to more later, for sure. Okay. Can anyone help me with the pronunciation of this name? Kaustub Old Podkar? Kaustub Old Podkar? Any chance that that was kind of close? Okay. We will be getting going in just a second. I'm waiting for the live chat to maybe catch up to me and somebody might help me pronounce this name correctly. All right. Close enough, I think. Well, that's what it's going to have to be. Where's my marker? Here we go. And I'm going to get started. I wish I could just call and pronounce it. Ah, that's a good point. You could, yeah. Let's move on. There's probably some fancy technological way we could make that happen. Oh. Everybody should stretch. Everybody stretch. This extra live stream towards the end of the day, trying to do something with machine learning and TensorFlow.js, this really needs some space melon. But I don't have any space melon with me, so I'm just going to have to try my best. Kustub, thank you. Kustub Old Podkar. Okay, thank you. Kaustub Old Podkar. Okay, now people are just trolling me in the chat by saying it's pronounced with the actual spelling of the name. I will do my best. Hello, you are here watching another coding challenge, and this coding challenge, maybe this should just fit and be in one of my tutorial videos, but I'm going to make it a coding challenge because I'm going to attempt to do it in one video. And what I'm doing is recreating something that I've done before in some of my machine learning tutorials. And it was suggested here, I don't know if it was suggested exactly, but a Twitter user, Kaustub Old Podkar, apologies if I'm pronouncing the name incorrectly, created this interactive simulation of linear regression using TensorFlow.js. And so this is very similar to something that I've done previously, right? I have this video, linear regression with gradient descent, where I just did this with plain JavaScript. And then you could also look at this other video, which I go through the mathematics of gradient descent a little bit. But here's the thing. Going through the mathematics, making this video where I implement the mathematics in JavaScript while useful, and perhaps background for this video, one of the exciting things about doing this with TensorFlow.js is TensorFlow.js has a nice API for optimizing loss functions with the gradient descent algorithm built into it. So I could just do things. So let's make a list. I got to come back here, but let's make a list. Oh, hold on. Hold on. The things that I'm going to need, right? I need to have, okay, so what's going on here? What is linear regression, first of all? And of course, you can compute the, let me do that again. I was going to do this as a coding challenge with no editing, but so much for that. All right, so first of all, what is linear regression anyway? So let's say we have a space, and I drew this as like a canvas, but really I should be talking just about a generic kind of two-dimensional Cartesian plane. And in that plane, there are a lot of points, and I don't like the way I just drew that. In that plane, there are a bunch of points. The idea of linear regression is to figure out, can we fit, oh, this is a time for another colored marker. Can we fit a line into this two-dimensional space that approximates all of these points as best we can? And I can visually just kind of make myself do this like this. So I can eyeball it and say, this line kind of gets close. What we're trying to do is minimize all of these, this is the most beautiful diagram I've ever made, all of these distances of all of the points to the line. The idea here then is that we can make some predictions, right? If this data, if this x-axis, represents height, we might predict on the y-axis weight, right? You can think of kinds of data sets, simple 2D data sets, where there's a linear relationship between the one field of data and another field of data. So if we pick a new height, we can kind of make a guess approximately what that weight is going to be. That's the idea of linear regression. It's incredibly simple. A lot of data isn't two-dimensional. A lot of data doesn't fit a line. Maybe a curve fits it better. And this is more complex scenarios will come as we move forward and make more scenarios with complex polynomial equations or neural network-based learning and other types of machine learning algorithms. But this is a good place for us to start. So what do we need? We need a data set. So we need a set of x's and y's. This is the data set. Right? We need x's and y's. And I'm going to create that data set through interactive clicking. Interactive clicking is the way I'm going to create that data set with the mouse. I need to have something called a loss function. The loss function is a way of computing the error. And there are a bunch of different loss functions, and we'll see these as I use TensorFlow.js in more tutorials. I can select different kinds of loss functions for different scenarios. But in this scenario, I'm going to use a simple basic one, which I believe is called root mean squared error. Did I say that correctly? Is that the right name of it? But the idea is that I want to look at all of those distances and I want to minimize them. So that number, if I find all these distances, the difference, and by the way, I botched this. Time out. Vertical distance, it's even in the chat. So the good news is you can barely see it. I'm looking over here on my monitor, and now I can't see it. You can barely see it, but I really botched what I was drawing there. So let me fix that. I don't think I'm going to go back and redo this video. I think I'm just going to get a different pen color since you can't see it anyway, and just fix that. So, little editing point here. Okay, I'm back because I started talking about the loss function, and I realized I really didn't draw. I'm not actually looking for the distance from the point to that line, which would be perpendicular. I'm looking for this vertical distance, which is, so this is what I'm trying to minimize. Right? I'm trying to minimize and get a line that has, and this, that has the least, the sum of all these distances is the smallest number, minimizing the loss. So I have a loss function, I need that. I also need, in TensorFlow.js, something called an optimizer. And the optimizer is the thing that allows me to minimize the loss function. And in order to do that, I also need to have a learning rate. So these are all, I actually missed something very important here, but these are all the pieces. I need the data. I need to define a loss function. I need to define an optimizer. I say, hey, optimizer, minimize the loss function with this learning rate. So keep tweaking the parameters, So that's the thing I forgot. What are those parameters? Well, the formula for a line is y equals mx plus b. M is often referred to as the slope, b as the offset? What's the name for that? You'll tell me in the chat. Uh, what's the name of that? Formula for a line. See, this is why I shouldn't do these live streams at the end of the day. I was so with it when I was talking about promises this morning, wasn't I? Y-intercept. There we go. Y-intercept. Okay. I'm back because I looked it up. M is the slope, and B referred to as the y-intercept. Kind of like bias, by the way, if you've watched some other neural network tutorials, because this is like the thing we're doing with all the neurons. Oh, it's all so connected, but we're just living in this very simple place. So I need these parameters, I need these variables, because that's what's going to allow me to create the predictions that are on the line to compare with the actual points and compute the loss, minimize it, tweaking these values. So tweak these values, minimizing the loss. This is what we're doing. And I've done this before in great detail. This is going to be in less detail because TensorFlow.js is going to do a lot of this for us. The thing that's a little extra complicated is we can't just work with arrays of numbers and variables in the way that we're used to in JavaScript. And so this is what brings me to, if you haven't looked at these particular videos that I've made already, what's a TensorFlow tensor, what's a variable, what's an operation, how's the memory management stuff. This is stuff we're going to have to lean on while I build this example. And this should be, by the way, an actual practical example of where I need a TF variable. So I kind of in this video explained what a TF variable is, but just kind of moved on and didn't use it for anything. So hopefully this will show us that. All right? How about we write some code now? All right, I'm pausing for a second, taking a look at the chat. The root shouldn't be there. I don't know what that means. Offset is fine. Y-intersect or intercept. What's the root? Oh, the, so what's the, let me look this up on the, what's the wire mess? Oh, in the back of my, yeah, let me fix that. What's the, why did I say root? Let me look at loss square. Oh, because I don't have to square root it. Mean squared. Yeah, so I'm going to just use mean squared arrow. Thank you. Thank you. Simon in the chat, in the Slack group, makes a good point. So maybe I should correct that really quickly. I am not going to be doing partial derivatives again. Definitely not, asked Kenneth. So maybe I should go back and define that better. Root mean squared is... oh, okay. So actually, I magically appeared over here for a second because instead of, I did make a little mistake here. I mean, root mean squared is a perfectly legitimate loss function, but most linear regression with gradient descent examples will not bother with the root. And the root refers to square root. We just want the mean squared error, which means like if I say that this value is y and this value is like the guess, right? The error is guess minus y and squared. And if I do that for all of these, that's the mean. And average them, it's the mean. So I can really sum them or mean them. Well, it's going to take care of that for us. So we're just going to use the mean squared error. But that's the idea. We take the differences. The reason why we have to square it, well, for a variety of reasons. One, it has to do with the derivative stuff that's in my other videos, but also just because positive or negative, it's the distance, the size of the error, whether it's up or down, which is key. All right. So I need to start the coding, but the microphone is making me crazy right now. I need to tape it to my ear. So hold on. I just need to get a little piece of tape. It really distracts me when the microphone starts. Yeah, by the way, Ricardo in the chat is mentioning the Coding Train hoodie. This is a new Coding Train hoodie that will be available later today. All right, am I good to start coding? Any last comments before I start coding? This feels, it's staying on my ear now. Okay. And maybe next time I'll get the lapel mic back. How are we, 4:51? We're doing pretty well. To check I'm just gonna keep going. All right. I think I'm good. I think we're ready to start writing some code. All right? Where's my marker in case I need it? Over here. All right, so here's the amount of code we're going to start with. I'm using P5 so that I can draw stuff. I'm making a canvas, and the background is 0. Which means it's black, and this is what I have so far. So let's look at our list over here, and let's first add the data set, the x's and y's. So this is going to be easy, because I just want to have x's be an array, y's also be an array. So, and then, whenever I click the mouse, I want to say, oh, you know what I could do? I could make those vectors, let's make them separate arrays. I think we're going to, actually, I know we're going to want to do that for a variety of reasons. We're going to keep those as separate arrays. So every time I click the mouse, I'm going to say x's push mouse x, y's push mouse y. Ah, okay. here's a little thing. So this is our canvas, right? This is my drawing of the canvas. I know now I'm having like a deja vu thing. I totally talked about this in the other video. The width is like 400, the height is 400, but I really want to think of this as, I really want to think of 0, 0 down here, and maybe 1 being over here. I want to normalize everything between 0 and 1. Everything's just going to work better if we do that. So with y pointing up. So I'm going to do a mapping. So every y value, that's pixel value between 0 and height, I'm going to map between 1 and 0, and every x value that's between 0 and width, I'm going to map between 0 and 1. So let's do that. So I'm going to say let x equal map mouse x, which goes between 0 and width, to between 0 and 1. Let y, which is mouse y, between 0 and height, and have that go between 1 and 0, and then push x and push y. So the other thing I want to do is I just want to, I'm going to add a draw loop, and I want to draw all those points. So I'm also now going to say stroke 255, stroke weight 4, for let I equal, what? Huh? Let I equal 0, I is less than x dot length, I plus plus, and those are actually called x's, x's dot length, and what I'm going to do is I'm going to say let pixel x equal map. I really should make just like, I'm probably going to do this a lot, so I should probably make a function that just like normalize and unnormalize or denormalize. Px equals map x's index I, which goes between 0 and 1, back to 0 and width. So this is the reverse. Py, which maps y, which goes between 0 and 1 to height, comma 0. And then I want to say point px, py. So I haven't done any, I'm not even using TensorFlow.js yet. I'm just kind of doing the stuff with P5 to draw things. So let's see if I'm getting the results that I want, which is whenever I click, I get the points there. Perfect. And I kind of want to see them a bit more. Let's like really make it bigger. Great, that's like too big. Okay, great. So we can see those are the points I'm clicking on. Okay. Pause, edit, edit, pause, edit, edit. I'm like drunk with power with the editing. I just take a break. It'll get edited later. I used to say that and it didn't. Now it does. I think it was probably better when I didn't stop in the middle. All right. All right. So what's next? I need a loss function. I need an optimizer. Oh, I need these. Let's make these. So, because I'm looking for somewhere where I need to get some TensorFlow.js stuff working. So what I need is I need to have M and B. So let's figure that out. So I'm going to create an M and a B. And I'm not going to initialize them in setup up here. And I probably should be using const in various places here to protect myself from reassigning something by accident, but I'm going to be loosey-goosey and just use let. These could be const. But anyway, I'm not going to get into the whole let versus const thing. It makes me crazy. I'm going to say up here, M equals TF scalar random 1. So I'm going to use the P5 random function to give me a random number between 0 and 1, because I got to start somewhere. So this is kind of like initializing the weights of a neural network. There is no neural network. I'm just kind of optimizing this function, y equals mx plus b, but those are like weights, m and b. So I'm going to initialize them randomly and scalar because it's a single number. So go back to my TensorFlow.js intro videos and you'll see. Then b, I'm going to say the same thing. But these are the things that have to change, right? The data never changes. It's sort of fixed. M and B change over time. I need to tweak those, which means they have to be variable. They have to be able to change, which means when over here, I think what I write is TF variable. I wrap them in the TF variable. So now I have M and B as TF variable, right? Isn't it crazy? Like you see this kind of code and you're like, that looks like the craziest, scariest thing. But you realize like it's just like make a number. And because we're in this like kind of lower level, working on the GPU land, I've got to be very like specific. Like this is a single number and it's going to be variable. But really it's just a random number. Okay, now what do we need to do? We need to write, I don't think I actually said this, but I need to write a function called predict maybe, which takes in all of the x's, just the x's, and gives me the y predictions based on where the line is, right? Because I need to compare the y predictions to the actual y values to get the mean squared error. So let's write that function. So I'm putting these in like arbitrary places, but I'm going to write a function called predict. And there what I need to do is I need to have some x's, and I need to return some y's. I think that's the idea, right? Yes. So I don't want to just predict one value. I want to predict a bunch. So the x's, here's the thing. So if I call this function, the x's, if they're just a plain array, I need to make it into a tensor. So I'm going to call it const tfx's. That might be is tensor. And this is a 1D tensor. Tensor 1D. TF. Tensor 1D. I think this will do it. X's. Right? I need to turn it into a tensor. And then I need to have the formula for a line. So I need to say, which is y equals mx plus b. So what I would be doing is I would be saying TF x's multiplied, is it MUL or MULT? Multiplied by m plus b. Right? This is the idea. If I'm getting just a plain array of numbers, I turn them into a tensor, then I apply the formula for a line, and these are the predictions, the y's. I guess if I don't like my naming here. I'm just going to call this x, and maybe I'll call this x's. I don't know. I have to think about, I'll come back to this later. Okay, so I have that. Now, let's go back and look at the things that I need. So I have this predict function. I have a data set. I need a loss function. I need a loss function, and I need before we do the loss function, let's create the optimizer and the learning rate. So this is what's wonderful about working with TensorFlow.js. When I say make the optimizer, I just mean make a tf.optimizer. Like it exists. It'll do this math for us. So let's go to the, this is not something that I covered in my other videos. So let's go look for optimizer. And I want an optimizer. Now there's all these different kinds of optimizers. SGD, stochastic gradient descent. This means the idea of slowly adjusting M and B to minimize the loss function. And I've covered this in more detail in the other videos. So, so I'm going to click on that, and I'm going to look here, and this is basically what I need to do. All right, we got the code right here. Look, there's even a, look at this. Oh my goodness, there's like some stuff here we can really use. So I'm going to grab this, and I'm going to put this up here. So I want a learning rate, and I'm gonna have a much bigger learning rate to start with, and I want an optimizer. So now I have a learning rate and an optimizer, and the optimizer is doing stochastic gradient descent. So I have learning rate, optimizer. Now I need that loss function. I need the loss function. Okay. The loss function is something I'm gonna write, loss. And actually, let's go back to here. So look at this. So this is the fancy ES6 way of writing a function, but I'm going to write it in a less fancy way. And I'm going to do this. So what I want is I need the loss function. I have some predictions, and I have some labels. So these are, the predictions are the y values I'm getting from the predict function. The labels are the actual y values that are part of this. And by the way, I'm going to have to do memory management. Don't worry, if you're screaming at me that I haven't worked about memory management, I'm going to do that. I'm just going to do that later. So what I want to do is say return the predictions minus the labels. That makes sense, right? Because I said here, when I said mean squared error, is the predictions like the guess minus the labels, which is the actual y, squared. And so predictions minus the labels squared, and then take the mean of them. Look at this. All of these mathematical operations are inside of TensorFlow.js, and you can chain them. So predictions is a tensor, labels is a tensor. All of these, remember, they're just going to keep producing new tensors, and I'm going to have to tidy and clean all this stuff up for memory management, but again, I'll worry about that later. So now I have the loss function. All right, well, what is it that I want to do? Every time, so let's see, I think I'm actually like, I have everything. I have the loss function, I have the data, I have the optimizer, I have a predict function, I have a learning rate, I can minimize, well, oh, this I haven't done. So the training, the actual training, what does it mean to train it? To train it means minimize the loss function with the optimizer and adjusting M and B based on that. All right. So let's see if we can make that. I have a feeling that was in that page that I went to, so maybe I could just copy it from there. I'm kind of, this is like very, so it totally is. That's fine. I'm gonna happily cheat here. It was in that example. Thank you very much. Thank you, TensorFlow.js documentation. And so I'm going to just put this in draw. Like every time through draw, I'm going to minimize. So let's look at this. Oh, look at this. Okay, so this is a little different. So first of all, this is using nice, fancy ES6 arrow notation, which I'm somewhat happy about. But let me just write a function here called train. And the idea of the train function is to execute the loss with the predictions and the actual y's. Okay, so here what I'm really doing is minimizing the train. That's weird. This isn't really, no, training would be doing this. So this is a terrible name for this. And actually, this is silly for me to even name this. It really makes sense for me to just make this an anonymous function, and that what I'm minimizing is this, right? This is what I want to minimize, the loss function. But if I want to be nice and ES6-like with my arrow notation, which I think by the fact that I'm using TensorFlow.js, and you can watch my arrow notation function if this is, I can kind of get rid of a lot of the extra stuff here, and this should be good. So I just want to minimize the loss function. Now, here's the thing. These have to be tensors, right? The loss function requires predictions and labels. They have to be tensors. And if you remember, my x's and y's aren't tensors. When I call the predict function with the x's, it gives me back a tensor. So that, I can't believe I haven't run this code yet. This is a terrible thing. Usually I try to run my code incrementally all the time. I guess I've forgotten to do that. So probably people in the chat are telling me about mistakes I'm making. So this is a tensor, but this is still a plain array. So what I need to do is say constant, and I got to rethink the naming. Maybe somebody in the chat has an idea for me. I think what I actually should do, I have an idea. Permit me a moment of refactoring. X vals, Y vals. So I think when it's not a tensor, I'm just going to call it like X underscore vals, because that's going to help me remember. So X vals, Y vals. And then whenever I say, and this should be X, whenever I say XS or YS, that's really a tensor. I guess I could have done TXS. So here, what I'm doing is predicting from the X vals, and then YS is TF tensor, shoot. Somehow I went past a half an hour. YS is TF.tensor1D Y vals. So I need to create that tensor, and now I can minimize the loss with predicting from the X vals and the Y vals. Okay, so this is good. Let's just run this. See what errors we get. Okay, predict.sub.squared is not a function at loss at optimize or minimize. So what do I have wrong here? In my loss function, sub labels dot squared dot mean. And so let me put no loop in here because I just want to run this once. And let me say, I just want to like console log. Oh, actually I can just do ys.print. Oh, you know what it is? There's nothing in the arrays at the beginning. They have 0 things in them. So a couple things. One is I could put something in it, but I think I probably should just say, I shouldn't do it only if x.length is greater than 0. So this is definitely, that do I want to bother with? Do I want to bother with doing any of this? If there's no values in there, like calling predict and stuff with an empty array, I think is going to cause problems. That makes sense. All right, let's try this. X is not defined. X vals, my naming. Okay, sketch 45. This is X vals. And this is X vals, Y vals. Okay, that should be good. All right, let's try this. All right, I think I have frozen the world. This is not square. I'm being told in the chat, breaking news, that this is actually dot square, not dot squared. Is that right? Operations, square. Oh. Whoa, this I might be able to use. Computes the mean squared error between 2 tensors. So I could also use this probably, but that's not what I'm looking for. It's square. A dot square, okay? So hold on. So what's going on? Let's comment this out. Oh, did I put no loop? I put no loop in there. Silly me. Okay, everything's fine. I put no loop when I was trying to console log stuff. There we go. Okay, so things are going, and there's no, I don't have any, like I could look at, that's m.print, right? So you can see it's changing. It's actually like training it. Like the value of m is changing. So everything's going and working. The problem is I'm not seeing the results. Let's just check B. And I haven't done any memory cleanup. So if I say memory.num tensors, is that what it is? No, what is it again? So let's look under memory management. Memory num to, this, TF. So I know you can't see this, but this is what I want. I want to check how much, I want to check and see like how, if I have cleaned up stuff. You can see I have 1,147 tensors. So I need to do the memory cleanup. I don't know, probably better practice would be for me to clean up as I'm going, but I'm kind of going to clean up at the end. All right, so I just want to click back here for a second. Oops, no. I'm just going to click no loop to shut this off. And let's go here. So what do I need to do? I need to visualize what's going on. All right, so how do I do that? So I need to draw a line. So the way that I would draw the line is first what I would do is all I really need is to give myself the x value of 0 and the x value of 1, get the two y values, and draw a line between those 2 points. So if I were to say, let x equal tf scalar, this is silly for me to use the predict function. Why not? Why not? Let's use the predict function. Tf scalar 0, so x1 is tf scalar 0, y1 equals tf equals predict x1, x2 equals tf scalar 1, y2 equals predict x2. Right? So this should give me, I mean, it's a little bit silly for me to not just do this, keep an extra copy of like m and b as regular numbers, but let's keep going with this. Will this work? Is it going to be able to take a scalar and make a 1D tensor? I think so. So let me just see here. So let me do x1.print, y1.print. So let's see that. Tensor 1D requires values to be a flat typed array. So I could y1 equal, I could reshape. Oh, yes, good point. Minimize. Sorry, I started looking at the chat, which I shouldn't do. I'm going to pause for a second for a little edit point. Alex Pratt's-Ferrer writes, you need to average the squared error. I don't think I need to average it because I have the dot mean function. So that takes the average automatically, I think. So let me think. What might be better is for me to just, I should just bite the bullet and get the m and b values back, right? Yeah. I could reshape this. Wait, oh, no, this is silly. I can just do this. Hold on. All right, so one thing I could do is instead of making it a scalar, I can make it a 1D tensor. That's what it wants. And do the same thing here. And I have to put it in as an array then, but it's just one value. Oh, this is so silly. Why am I doing x1 and I could just do this, right? X's, once again, can I use X's? Yeah. So I could just do it with 0 and 1. Constant X's, and then constant Y's equals predict X's, right? So I could have both these points now. Then, let's say X's.print, Y's.print. Let's look at that. Let's see if this works. Predict is not defined because my E key doesn't work. I have to type it several times. Tensor 1D requires values to be a flat typed array. Oh, silly me. Predict doesn't want a tensor. Oh, it wants this. So line x equal, this is a little bit silly, but I'm going to do this. So I'm going to make but I don't need to know the x's. I don't need to have the x's as a tensor because, yeah. Sorry, everybody. There we go. My predict function, I totally forgot already. See, this is just, there's so many different ways you could do this. Like I could enforce you to convert to a tensor before you pass it into predict, but a lot of these decisions are completely arbitrary. So you might have a better way of doing it, but still I'm going to do this. So now I have the x's and the y's, and I don't even need to say xs print. So we can see, okay, great. So I'm getting these points. Kay Weekman in the chat makes an excellent point, which is that I should think about actually mapping it between -1 and 1 with 0, 0 in the center. That's not such a bad idea. Let me just keep going with this, and then maybe I'll change that after the fact, because this should work anyway. So now here's the thing. Here's the awkward thing. In order for me, all I need to do now is basically say this. Let x1 equal map x is 0, which goes between 0 and 1 between 0 and width. And this is kind of silly, because I could just multiply it times width. But I'm going to just go with the normalizing, the full normalizing. Y1 equals map x2, which map x is index 1. So this gives me x1, which is just 0 and width. Now, y1 and y2, I want to map ys, the y values between height and 0, because I'm flipping it. The problem is, and then I just want to say line, x1, y1, x2, y2. So this is really all I need to do, right? I just want to get the sort of 2 points on the line and then draw a line between them. This is fine because my x's are not tensors, and I can use plain numbers right here, x1, x2. But my y's, and here, but my y's are tensors. So for me to be able to, I really need to get the values back. And a way to do that is with the function called data. So I'm going to say let line y equal y's.data, and I'm just going to say data sync right now. And let me comment all this out, and let me console log that and see if this comes. So this is kind of a bad idea for a variety of reasons, but I think it's going to work okay. So you can see I'm getting those numbers back as a float array. So here's the thing. This really requires not a callback, but a promise. And I'm so happy I just did a whole video series on promises. I really should be saying data.then. And there's even something called TF NextFrame, which allows me to sort of think about the asynchronous nature of pulling the data out of a tensor into a number that I can use in an animation. These are key things, and I'm definitely going to have to get to them. But here's the thing. This is just 2 numbers. I think my animation can handle using data sync, and maybe somebody from the TensorFlow.js team is going to want to say, like, actually, this is not just a bad idea, but like a really bad idea. I'm not so sure, but I think it's going to, let's just get it to work and see if this demonstrates the idea. So now, and I'm going to call this line y, I should be able to say y1, y2, and I should get 0 and 1 from line y. And now, we should be done. Oh, line y is not defined. Where? Sketch.js line 61. I think I just didn't hit save. Yeah. Oh, I haven't clicked any points. Hey, look at that. Oh, hey, look, it's working. Oh, that's so exciting. All right, for a couple things. Number one is, let's say stroke weight 2. And by the way, we can now start to play with the learning rate. I know I have to clean up the memory stuff. We can play with the learning rate. Like, let's make this 0.01. So you can see what happens with a lower learning rate. I don't know if it's, let's see, is it really working? Well, I shouldn't use such a low learning rate. Let's make it 0.5. Yeah, it's definitely happy. Okay, so this is working. Linear regression with gradient descent, but I have a severe problem. I am just filling the GPU with tensors and tensors and tensors and tensors and never cleaning them up. So now it's my job to go through and find every place I'm creating a tensor and dispose of it. So I can use tf-tidy to do that automatically, or I can just use the actual dispose function, which I might be inclined to do at first. All right, so let's go through. So here, these, I always want to keep them. M and B are variables that I need to keep throughout the course of this program. Loss, do I just put tidy in here? Or should I, let's predict. So do I put tidy in here, or do I wrap tidy here? What if I just put tidy here? Like, what if I say tf.tidy and put all of this? Will this do it? And then here, I also need to, well, here maybe what I'm going to do is just dispose these. There's no logic to what I'm doing, but I'm just going to dispose these manually. Oh, and that's just the y's, right? Line y is just, ys is the only thing that's a tensor here. So this should tidy everything, but hopefully not the variables that I need to keep, rather than individually figuring out what to dispose of. And down here, I kind of know that this is my only tensor. This, by the way, I should call this like line x, just to be consistent with my variable naming. I'm only using the ys and xs variable name when I have something that's actually a tensor, which helps me remember what I need to clean up and not. Let's see if this goes. Okay, it's still running. 221. Oh, no, okay. So I'm better. There's fewer tensors, but I haven't cleaned up everything. So what could I be missing? Maybe the call to predict. Wouldn't tidy clean that up? Yeah, we need a... I'm going to have to think about this for a little bit. Ferenc asked, just joined in, is it being recorded and posted later on YouTube? Yes. Anybody see what tensors I'm missing? This is like the laziest thing ever. There's got to be a good way to debug this. So this definitely gets cleaned up. The question, does everything that's made inside of the loss and the predict function get cleaned up? It would seem not. Well, hold on. Let's comment this out. It's not working, but no. Okay, that's good to know. Okay, hold on. All right, I need to debug this somehow. One thing I could do is start commenting stuff out to see like where is the memory leak. So one worry I have, I really think loss and predict, those functions generate a lot of tensors. I believe tf-tidy should clean up anything, but let's just, for the sake of argument, comment this out. And now, of course, the learning is no longer happening. And what I might as well do is console log the amount of tensors, not have to like ask for it. Whoops. What did I do wrong? TF memory num tensors? What is it? How come I can't remember what it is? Num tensors. No. Yes. It's not a function, it's just num tensors. Sorry, everybody. Okay. So, and I need another parentheses here. Little digression there. All right. All right, so we can see it's growing. So let's keep commenting stuff out to see like what's causing the memory leak. Let's comment out this whole area down here. Good news, everybody. The memory leak is in that part. Let's put this back just to be sure. Okay, so the memory leak is definitely down here. And I'm probably creating, oh my goodness. Oh my goodness. No, I'm not sure. Well, let's put this back in. I thought I saw it, but then I didn't again. So this is a tensor, and I'm disposing it. Oh, predict. Aha! The predict function makes other tensors. And predict got cleaned up because it was in tidy, but I'm just manually disposing the y's down there. That's what it is. So let me use tidy. I guess, so let me do this. Let me put this up here. So this is really what I need to tidy. So instead of disposing manually, I kind of like disposing things manually. The tidy thing kind of freaks me out. But the problem with this is I have a scope issue, which is that line y, right? No matter what I do, if I take this out here, like this is going to tidy everything. So I guess it's not the biggest deal, at the moment at least, for me to just put everything inside the tidy. Well, let's put everything inside the tidy for right now. There's probably a way I could simplify that, but this should work. Let's give this a try. There we go. There's only ever 5 tensors all the time. So there's no more memory leak, 5 tensors, linear regression with gradient descent, TensorFlow.js, interactive, here it is. So what's left here? So number one, things that could be improved. Pause. Oh. So I could say, all right. So line y, ys, so I could actually just put a tidy here and have it return. Okay. So I wanted to talk through some things that could be improved, but already me in the chat made a very good suggestion. This is very awkward how I put everything in tidy, so unnecessary. Let me take that out. Because predict returns something, I can actually just put the tidy right here. I don't know why I didn't think of that. Like I can actually just, it's only this predict function so I can actually put the tidy right here. And I can use my fancy ES6 arrow syntax, right? And the return is now assumed. And then I can just say ys.dispose. So this should work, right? Tidy's not going to tidy up this y value, but I can dispose that manually once I have the values. So I think this will do the trick. Let me just take a look at this. Yeah. So this I like better. And there's probably other styles or ways you can do it. The point is you've got to keep track of all the tensors you're making and dispose them. Okay, pause, edit point. Let me see. What are some other things? Right, I could put use the data sync in there, but I'm going to keep that as a separate line. All right. Interesting. All right, let's add a few more things. Riza in the chat asks, can you print the loss? That would be really useful for us to see the loss. I could even graph it. So I'm sure there's a way for me to do that. I need to grab the loss somewhere. So the loss, I think the loss would come out here, right? I wonder if it would get returned. Let's just take a look at that. Oops. Oh. No. Hold on. I mean, I could call the loss function, but all right, maybe let's not. The return is implied sounds better than assumed. Yes, thank you. That's a good point. Hello, Izumi. Coding Train sponsor. Outliers. Hold on. What are some things that I can do to improve this? Adding the loss, I'm going to leave that as an exercise. So Mathieu, we're at the edit point where I was about to add some improvements. Anything else? Tensor board to visualize the training graph. It's 5:30, so I also have to go. I do think I completed this. I just want to check. I just want to just check. The reason why I have to go is because I have to be home at a certain time. And I just want to make sure it's not like an emergency for me to be home. Okay. Oh. All right. So I've got like 5 or 10 minutes. I think I'm good. Try another optimizer. All right. So these are things, but these are things I want. I think I want this video to be over. So you get the loss with a callback. Ah. Interesting. All right. Print mean squared error. All right. All right. So let me. Why don't you tidy the tensors inside the predict? Yeah, that would have been another way to do it. There's just so many different ways. All right, so here. Okay, so I think I'm going to wrap this video up. I'm getting all these great suggestions from the chat, right? You know, I could have tidied the tensors here in predict. You know, so number one is this code is going to get posted to the Coding Train website and coding challenges. Make your improvements and add them as community contributions. Some things that I would love to see. Visualize, graph the loss value. I think there's a way to get the loss. I'm sure there's a way to get the loss value out of that function. That's one idea. There was another good one that I forgot. Oh, yes. Kay Weekman suggested maybe trying some of the other optimizers. So what happens if I go to the TensorFlow.js documentation and like just use some of these other optimizers? What are they? What will they do? Do you get better or worse results? Can you make the learning rate somehow interactive? Adjust the learning rate? You know, I don't know if you could come up with any really clever visual ideas with this, but anyway, but I think I'm good. I think I have the basic idea. So if you really want to dive as deeply as you can into linear regression with gradient descent, you can go back and watch my other videos where I did this with just JavaScript and P5.js. Now you've seen it with JavaScript, P5.js, and TensorFlow.js. So I look forward to your feedback and hearing more about it. More TensorFlow.js videos to come. You know, I want to get to some actual more practical things that you might want to do for interactive creative arts projects, but I'm still in the weeds here of just trying to understand the nuts and bolts of how the library works. So I hope you're enjoying that, and I look forward to seeing you in future videos. All right. Put on hold. I am reading your comment. All right, so I am done for the day. I have done a lot of live streaming this week. I pat myself on the back. At least 5 hours of live streaming this week, which is pretty good. Hopefully that makes up for the weeks that I've missed. Next week, I think I might actually not be live streaming on Fridays this summer. I think I'm going to be doing like Wednesdays and Thursdays during the day, which is my New York time. But I'm kind of gonna. It's going to be kind of game time decision each week. Stay tuned. So what's the stuff you need to know about? So if you go to thecodingtrain.com and you click here to subscribe on YouTube, it will take you to the channel. Hey, yeah, I totally want to subscribe. I may not. Why not? I'm so close to 500,000, which is nuts. You can get 50,000 subscribers in the next like 10 minutes. That would be exciting. Look, it says I'm live now, which is this. But when I schedule a live stream, okay, I'm getting some important messages. I really got to go. Putting on my goodbye song. Let me just send a little text message back here. Yes, will do. Try asking it now. I missed it. There was a question. Show us the hoodie. People want to. So this hoodie, I don't know if is the hoodie available yet. Oh, the music's not working. Sorry about that, everybody. I forgot. I turned it off. The hoodie will soon be available on the store. Is codingtrain.storenv.com. So this is the URL for the Coding Train store, for those of you who are interested. But right now, if you go here, hoodie, that's a different hoodie, zip-up hoodie. I think, is this the new one or not? Interesting question. I think I have to see. Let's click on this. It's expensive. Yeah, no, this is the old one. So you could get this. but I'm going to change it. This is a new American Apparel hoodie. I like it better, and it also has the coding train on the back. Although this was the sample, so I'm gonna move it down to about here. If anybody has any suggestions or ideas, by the way, all of this is fulfilled through a website called Printful.com. So in theory, I have the capability to produce any, like a ton of like other things, but it's just not my priority, merchandise. I don't really know what I'm doing with that, but people were asking me about the hoodie. All right. Yeah, Printful ships internationally. It's not me who's sending it out. It's done through a print-on-demand service. It is marked up, so there's like a shipping and a slight markup. So if you buy the hoodie, I probably make like $4 or $5 or something. I don't know what the exact amount is. It sort of depends on what there's always like all these weird taxes and shipping things. But I don't. It's actually the Patreon stuff I actually mail myself. If you're funding through Patreon or whatever, but the merchandise stuff just gets fulfilled through the Printful store. I don't have to do anything. Do you know the Nair engineer question? Do you know any reference how to link processing-java to Atom? Yes. So what you want to look at is commander, processing command line. So you want to look at command. Hold on, don't worry. I know the camera went off, everybody. There we go. I think somebody's already done this with like an Atom plugin, but if you go here to this wiki, command line processing, there is a command line tool that you can install, and then you can have Atom like execute the sketch via a command line. So you have to like configure Atom in a goofy way. This has been done. I know it was done with Sublime. Atom editor processing.org. Yeah. So like yeah. So I have a feeling. Yeah. So you can see somebody's already done this already and figured it out. So you have to install processing-java, and these are the instructions. And then you have to add stuff to your path and that sort of thing. Okay. Let's look at the chat. Dan, why do you know everything? Asks Melon Goggles. It is absolutely an illusion. I definitely do not know everything, and I just know like just enough to like get through the tutorial, and then like if I were to go 2 steps further, there'd be like 100 things I don't know. And all of you have, I'm sure, seen my disastrous live streams where I get completely lost. If any of you try to watch some of my tutorials where I try to explain calculus stuff, you would see that I don't know everything. Okay. All right. So thank you for all the questions in the chat. I will answer the last question. Justine asks, what's up with the camera going off every 30 minutes? Have you ever watched the TV show Lost? Basically, this is the, what's the thing called? The hatch. I'm in the like Swan station, and if I don't press the button every 30 minutes, the world will end. That's why I press the button every 30 minutes. No, the cameras have these cameras are set to go to sleep, and many people have given me many suggestions to get them not to do that, and I have not successfully been able to implement any of them. That's kind of a goal I have for the summer for sure. Oh, did I just spoil Lost for people? I'm terribly sorry. The thing is, that didn't really spoil anything. A little bit. Lost is one of my favorite television shows. I need some, I'm trying to watch some stuff this summer. But anyway. Oh, blockchain. I don't think you're going to find me doing any blockchain tutorials. Sorry to disappoint. Would you possibly do a time series prediction with LSTM, recurrent neural network? See, an example of how I don't know everything. Yeah, but I got to figure that out. All right, thanks everybody. Thanks for watching. Mwah, mwah. I kiss my fingers like a chef. I don't know. It's a sort of expression that I've adopted from somebody else. If anybody knows what that reference is, that's crazy to me. Did I like the Lost ending? Not so much, to be honest. But when I think back about that show, it fills me with such like amazing memories. I was really into it. I listened to the podcast. So the ending, I forgive you, Lost, for that ending. It was fine. You did your best. I couldn't have done any better, that's for sure. That was not my favorite season of Lost. Sentiment analysis, I definitely want to do. Yeah. All right. So there's going to be a lot of edited tutorials coming out. Just to recap, there's, I think, 5 or 6 tutorials on promises, async, and await. And now this coding challenge of linear regression with gradient descent. I will see you all next week sometime. Stay tuned to... oh, hi, Coding Garden. Coding Garden was live streaming at the same time as me earlier today. Coding Garden seems to live stream like 12 hours a day. I don't know how that's possible. It's probably not that much, but there's a lot of Coding Garden live streams. So everybody check out Coding Garden, a sponsor of the Coding Train. Oh, I can't put on my music and do my goofy sponsor advertisement again. See everybody. I'm gonna play out the outro now. Why not? Because it's the end of the day. See you all later.
Let's find something we want to make, some crazy idea. We'll figure out.
By the way,
what it
my
takes
microphone
to
is still
make
going.
that
I
dream
can't seem to
appear.
figure out how to use
We'll
it.
try to understand now as we ride along again. Now hop on the coding train, coding train, coding train. Come along and join us as we light it up in code, using only our imagination as the road. Whatever you're conceiving, you'll start seeing what you're believing. Just hop on the coding train, coding train, coding train. Pick you all up at the station. We'll make things of our own creation. Fireworks. Attempt to make